I do these events at FutureBuild every year, and this time last year, we hadn't declared a climate and ecological emergency. Last Easter, when our MPs went for their Easter recess, they came back and Jeremy Corbyn somehow sneaked in a declaration of a climate and ecological emergency, and Parliament, for some reason, voted for that. Since then, everybody and their sister has declared a climate and ecological emergency, or it feels like that. And this sort of thing's happening as well. Last Friday's news. So these really are quite different times for different people, a different sensibility. And even FutureBuild's branding is what it's all about. And we have lots of organizations springing up out beyond the construction industry, but one of my favorites is close to my heart, which is the Architects Climate Action Network, who've got a stand across the way there. Now, we now live in an environment where 75% of the population live in local authority regions that have declared a climate and ecological emergency. Now, if you work for those local authorities, your members are demanding a response to that, because they haven't done just a declaration. They then said, we're going to be net carbon zero in a decade, which is obviously impossible, but it's an ambition that's noble enough. And those local authority officers are running around at the moment saying, what the hell do we do? So why should we care? Well, I care for these reasons. And I'm a bit scared about this sort of stuff. And this is a map I nicked from Vivienne Westwood. And it shows what will happen to planet Earth quite crudely, very simple diagrams that I can understand, if we don't do anything. And we are not doing anything at the moment. We're thinking about it. And you can see that the red stuff is uninhabitable, and I think it's inaccurate because I can't imagine anything in Australia is going to be inhabitable if they don't do something soon, very quickly. So why us? Well, the UK construction industry, well, not the construction industry, in the UK we consume 600 million tonnes of stuff a year. Every year we generate 200 million tonnes of waste. 60% of that, or 120 million tonnes, is the construction industry. 45% of all CO2 emissions are the construction industry. The design, the building, the maintenance, the occupation, the demolition of the built environment. The construction industry also consumes about 50% of all raw materials that are mined and harvested every year. So what next? Well, a lot of people are doing a bit of that. More people are doing a bit of this, and this is interesting because this is a cartoon my partner Ian Mackay did in about 1996 or 97, and we're using it a lot again. But I think some people are doing this. Can we really afford to save the planet, or our bit of it, the bit that we live on? So from my point of view, humankind needs to learn how to manage planet Earth's resources, and it's all about that. And I think that it's designers and constructors and makers who are the managers of resources. We manage resources. We choose what things are made of. And the talks that you're going to get during this day of people who've made very clear decisions about the specification of the stuff they'll use to make the things they want. And the problem we have is at the moment we exist as a linear economy where we take material, we process it, we use it for moments, and then we throw it away. We are the only organism on planet Earth that exists like that. We create a desert and move on. In the rest of the natural world, when it's healthy, waste from one ecosystem is food for another. And we're just not very good at it. Here's a photograph of the last 23 North American bison before 10 more were shot. So we have to drastically reduce our reliance on raw materials. And I think the circular economy provides many of the answers, and we'll be talking about this during the day today, where you turn those linear take, make, and throw away systems back on themselves so there's no such thing as waste, just stuff in the wrong place, and waste is actually not a word we use anymore, it's just a resource. I wrote a book about it. You can buy it at the RIBA bookshop. Just a plug. Four chapters that take you on a route towards the circular economy. I had a 5-month paid sabbatical by the University of Brighton. Thank you very much. And so I got to interview a lot of people who are actually doing this stuff. We're in a position now where there is some good news. The construction industry has halved the amount of waste it's created it creates annually since 2010. Nobody's wanting to invest in coal anymore. And I think it's our city-states that are really going to move things forward, because that's where everybody lives, and that's where, or most of us, and that's where all stuff comes together, and that's where all these linear systems are near each other and can start to join up. And what I'm talking about, to conclude, is this idea of mining the Anthropocene. Working with either the replenishable organic material and nurturing the natural world by doing that, or more importantly, in a way, at the moment, reworking the stuff that's already been made by humankind. We're in a world where there's more gold in a ton of iPhones than there is in a ton of the best gold ore. So why are we sending people down underground? There's more copper above ground than below. It's above ground, it's the Anthropocene, it's the human-made layer of stuff that wraps planet Earth. So mine the Anthropocene, close down the conventional mines, and nurture the natural world. And stop making sustainability the Mickey Mouse issue, this was a really good slide by someone working for the World Bank. I was at the Major Projects Association last summer. And I think we've got a different set of criteria. Consider refusing projects, Grimshaw and others, before you reduce the amount of materials you consume in your day-to-day business, before you start reusing, before you recycle, before you start specifying new materials. And our biggest challenge is not changing today. And while I've got you captive, if anybody's interested in joining me in the summer in Brighton in August, the University of Brighton, together with Rota Deconstruction and Bellestock, we're hosting a week-long School of Reconstruction. Next week, I'm writing a deconstruction tender for demolition companies. The City of Brighton Hove are gifting us a building that they are then going to deconstruct, i.e. slow down the demolition process. We'll audit what we get from that building, and that material will be used at the School of Reconstruction. So if there's anybody that wants to be involved in that, check me out. We've now got some really good speakers, and I'm going to hand over to them in a minute. Thank you very much. I'll introduce. Okay, our first speaker is Gary Newman, who's Chief Executive of Wood Knowledge Wales, and he's the chair of the Alliance of Sustainable Building Products. I'll just leave it at that, actually, Gary. You get on. Thank you.
Great. Morning, everybody. Good to see almost full. Not bad at all. How Sustainable is Timber is my title. Like that? Can you hear me now? So I've got about 12 minutes. I mean, timber's right, it's pretty sustainable. In fact, the word sustainability was first coined around the sustainable planting and growing and utilization of timber when we realized quite a long time ago, maybe 200 years ago, maybe longer ago, that actually we needed to replenish the timber that we were using and do that continuously. So it's pretty sustainable, right? So the standards on supply chain were developed for forestry long before other material uses. I'm a big fan. We talk about the crisis, and there is a crisis, an absolute crisis, but within this room we have lots of solutions. I was on a stand this morning where you can build passive house with timber frame, timber insulation, all wood fibre, everything comes from the tree to create that fabric. The window frames, except for the glass, from timber. So there is a solution there. So all we've got to do is roll that out at scale. One solution of many. So I operate out of Wales. So I'm the Chief Exec of Wood Knowledge Wales, which is a for public good organisation that is aiming to turn Wales into a high-value forest nation. Think Austria, think France, think Switzerland, think, in fact, most countries in Europe, except for a few. The UK being one of them, largely deforested, and we don't recognise the value of trees at all. In Wales, we're turning that around. Timber is the only advanced industrial material whose greater use will also help to defeat climate change. I'll talk a bit more about that. So this is projected global GDP growth, a little bit older slide, I apologize for that, but I like the colors and the graphics. What it shows is projected threefold increase in GDP over the next 20, 30 years. That's population growth, not so much population, more the raising of living standards for the vast majority of people on the planet, which is a great thing. But that means the trebling of all the resources we use on the planet. An incredible, incredible challenge. But we can do that, certainly, with timber. And the demand for timber will at least treble. And as we shift to more renewables, probably more than that. Challenge for the UK, we're the second largest importer on the planet. Second only to China, quite a staggering fact. But what we do have in the UK is a huge amount of space to grow trees and to grow more trees. And the fabulous thing about trees is they grow on land where you wouldn't want to produce food, right? They grow on land like that. You can't get a tractor up and down that sort of land. So it's an obvious use for our landscape, particularly in Wales. So we have a plan. I have a master plan to get rid of these white things. So Snowdonia, I live in Snowdonia. You might think it looks beautiful. It's completely devoid of life because of these little beasties, subsidised through the Common Agriculture Policy, which is probably going to be removed. So that will help to shift to a more natural, more wood-based landscape. And there might be some rewilders in the room. I'm not a rewilder. For me, rewilding's a lie. It's a bit like taking back control. It's alluding to an imagined past that never really existed. The planet was wild before humans arrived. We have always shaped our landscape. The challenge now is to shape our landscape sustainably with trees. And there's been FSC standards and forest management standards for a long time in the UK. The plantation forestry of the 70s is the past. That is all now being transformed into much more mixed trees, mixed landscapes. But there's always a compromise, right? You can't have maxed out biodiversity, maxed out productivity, maxed out amenity. There's always a compromise, but we can have it all with good planning. And here's an interesting fact, that despite the subsidy, and there's no subsidy for forestry in Wales, very little, it's still worth more to the Welsh economy than the sheep. So, but you know, trees don't just deliver a resource for us to build with, they also improve the soil, water, air quality, and provide biodiversity and amenity, as well as this fantastic material. So what's not to like? I challenge anybody to say it isn't part of the solution. And if you have any doubts, here's an interesting little pie chart. The shows man-made, climate change, 2/3 being caused by burning of fossil fuels, 1/3 being caused largely by deforestation across the planet. Gives us a bit of a clue that trees might be part of the answer. So I put it to you that timber is the exemplar material for modern, high-performance, critically healthy, low-carbon construction. People like to live in wooden houses, not just from the aesthetic aspect, but also the breathability of the timber and the systems create nice, good acoustic internal environments as well. Yes, you need good design, but it's the material that can achieve that the easiest. Moving to off-site, so manufactured systems, there's quite a few shown here, factory-built, advanced solutions so that you can achieve passive house levels repeatedly over and over again, rather than reinventing a house every time we build one. We're moving to that. That can be done now, and is being heavily promoted in Wales. The thing about using wood is it does two key things in terms of climate change, leaving aside the trees, which everybody knows is the only carbon capture and storage system that works on the planet. So, but by using timber, you displace the high carbon intensive materials. So the top pie chart is UK's carbon emissions. Apologies if you can't see it from the back. So the top chart is complete UK emissions. The blue section is our industrial carbon emissions, which admittedly is reducing because we're offshoring our manufacturing, which actually doesn't solve climate change. It just means that the emissions are not on our budget. So those are our industrial emissions. The bottom one breaks down those industrial emissions into the different material sectors. And as you can see, steel is 25% of our industrial carbon emissions. Cement, even though we're largely an industrialized nation and not now producing much cement compared to China and other developing nations, is still 20% of our national material carbon emissions. So that's quite staggering. So it also gives a clue as to where some of the problems are. Now, this is a little bit tongue-in-cheek, and you could add glass to this list. You know, these were the wonder materials, and are still the wonder materials for our industrial world. They give us all this utility, but should we be using them in low-value, high-volume applications? Should we be using them without thought to their carbon intensity? They're fantastic, we need them. Steel, we clearly still need steel, but we need to use it more thoughtfully. We need to use it and reuse it. We need to design for its reuse. Cement, we need to use less of it. We need to use it in those applications where nothing else will do. Plastics, clearly, well, that's highly topical. Glass, you could add to the list. Should we be producing glass facades? Massively high carbon intensive facades that have about a 40-year life? No, we shouldn't. Windows, yeah, but not big glass facades. So I want to finish up with a little project that we're working on in Wales. Wales is getting into this agenda in a big way, thanks to, I would say this, Wood Knowledge Wales, where we're bringing together public housing developers who build 1 out of every 3 houses in Wales, soon 1 out of every 2, committing to using timber, committing to delivering net zero carbon. So this is a project, not a very good picture, I have to say, but it's a project we're working on, 37 houses in Wales, which is a medium-sized development. This is phase 1. Phase 2 is going to start next year, based on homegrown timber, wood fibre insulation, timber windows, local timber cladding, built to standard costs. And what we're doing now is measuring the performance, both in terms of operational carbon and embodied. We haven't done the operational carbon yet because they're not occupied, but embodied carbon we have. These are the RIBA Climate Change Challenge target metrics. If you look at the embodied carbon, which is the middle row, we're particularly interested in this conversation in the 2030 target for embodied carbon, which is less than 300 kilograms of CO2 per square metre. For the project that I've just shown you, we beat that quite substantially, about 20% using timber. And I can't prove this to you here, but earlier presentation on a stand over there said that timber frame is the only way, and using natural insulation is the only way that we can beat the 2030 RIBA challenge target. So I don't know about that, because all I've done is measured the project that we've worked on. Embodied carbon is pretty significant, right? These show that it's about, on this particular project example, it's about 50% of the total whole life carbon emissions from a project. So embodied carbon is unregulated, but it absolutely should not be forgotten. If we're going to deliver net zero carbon, we have to massively reduce our embodied carbon. And I would just mention on the housing project that we're working with the Housing Association, who are going to plant trees to offset their embodied and operational emissions over a 60-year life. And we've calculated that the cost of buying the land and planting the trees is about 1.5% of the total development cost. So it ain't that great. So it certainly can be done. Just to finish up, really, I've got a minute left. Just want to fly through some technical innovations which some of my colleagues speaking after me will talk much more about. But we're starting, in my opinion, at the golden age of the use of timber in construction. So you've probably seen projects made from this material, CLT, not just low-rise, but also medium-rise projects. That replaces all the concrete, nearly all the concrete that you would typically see used in construction, and a colleague from Wharf Thistleton will talk much more about this in a moment. We're also starting to explore ideas about super high-rise. This is a theoretical project, I don't think it's got, this is Sumitomo Forestry in Japan, but that gives you an idea of what might come. And we're not just talking about the structure, we're also talking about the insulation. Also, there's fantastic innovations in joinery, and a colleague will talk about that shortly, which is making wood a much more durable material for window manufacturers and other external environments. So, yeah, I would say wood is highly sustainable, and it is the only advanced industrial material available at scale right now that we could use more of and mitigate climate change at the same time. It's the material for the climate emergency. Thank you.
Thank you, Gary. Amazing facts and figures. Thank you. That was really inspiring. Right, I want to introduce our second speaker, who's Alistair Ogle from War Thistleton Architects. He believes that architecture should make the world a better place, both socially and environmentally. Applying this to his work, he designs with social and climatic issues in mind to ensure a building's function and appearance can adapt with time. Thank you.
Hi. Welcome, everyone. So my name's Alistair. I'm from War Thistleton Architects. We're a small practice of architects and problem solvers in Shoreditch in London, where most of our projects are inner city projects, so offices and houses, and we specialise in trying to find the most sustainable way to design those projects. And over the years, we found that typically the answer to deliver the most sustainable project is actually to build in timber. And so that's actually led us to be sort of world experts in building tall timber. So now we consult on building tall timber all around the world. But when we get a project, we do look at it from the outside of what can we do in order to reduce. Do we actually need as much material in the projects? Do projects need to be as big as some clients' ambitions actually set out for? So what can we do to reuse as much material already on the site? What can we do to reduce the amount of material? And what can we do to enhance the project to allow it to be easier to be recycled in the future? And our main focus with carbon has been on embodied carbon, or as I'm increasingly hearing it called, upfront carbon, which is if we're to hit targets for 2035, 2040, 2050, whatever year people pick, it's really soon targets. We need to be worrying about what carbon are we producing today and what carbon are we using over the next 30 years. And so we've really focused on how we cope with embodied carbon and how much carbon can we save today. So why do we select timber for most of these projects? So we select timber because it's a renewable material. The forest absorbs CO2 from the atmosphere, gets turned into logs, processed into these modern mass timber products, which we can lock away that carbon for over 100 years into buildings. And then once those buildings are demolished, the materials can be graded and recycled and reused, and those that can't can be used for generating low energy, where the CO2 is created and that feeds the forests. And so it's a cyclical, recyclable, renewable material. And so how much carbon can you actually look to save in a project? And so some of these figures are based on A1 to A3 in a life cycle analysis. And so what we've done is we've created a building typology, which we've designed as efficiently as we can in set materials. So we've designed it in timber, we've designed it in steel, and we've designed it in concrete. And what we're looking to do here is to show you the difference of the materials. So if you don't count for any of the carbon sequestered in the timber, so if you don't allow for any of the carbon that the tree has taken from the atmosphere, put inside itself, and then you lock away in the building, timber is still significantly less embodied energy than concrete. So these figures are for kilograms of carbon equivalents per metre squared. So timber's 180, concrete 220. But if you do count the amount of carbon sequestered in the timber used in the building, you get a significant difference in how much carbon you're saving. And so you've got to consider how much carbon the trees have taken out of the atmosphere, locked in the timber, and then you've locked away in a building. And then what's also never counted is if you're using timber from sustainable forestry, which is what we all specify in the UK, it'd be very tricky to specify a CLT building made of non-sustainable timbers. And typically, FSC or PFC state that you need to plant at least one tree, typically 2 trees, but well-maintained, sustainable forests actually plant up to 5 trees for every tree they chop down. And so in that 100-year lifetime, even in 30 years, so this is a 30-year chart of how much carbon is sequestered in the 2 extra trees planted during the 30-year time of the building. And then actually, because we're not building a concrete building, we're not building a steel building, we're actually saving all that energy from carbon from ever being spent. So the real carbon saving from building in a timber building can be dramatic. And so very quickly, what is CLT? We've seen a few photos, sorry. So CLT is taking standard softwood planks of timber, and different species of timber can be used, taking them at different standard plank format and then cross-laminating them, so sticking them together with glue under high pressure in alternate directions, which allows great stability and great strength in panels, and it also means you can have panels of great sizes and thicknesses without providing great strength, but from small materials. And so in 2009, we finished a project called Marry Grove, which was 29 homes built all out of CLT in a honeycomb structure style. So all the walls are the same thickness, made from CLT. It took 49 weeks to complete, and 29 homes completed. And you can see that it was so quick to fit out because actually we got most of the internal walls were structural as well. So we were able to create, when the main structure went up in 4 or 5 weeks, we actually had a big bulk of the work already complete. And since then we've been learning and creating more and more homes. But unfortunately the government's changed the rules on how we can use CLT in buildings, and so we've had to adapt how we design buildings. So we wouldn't be able to design this in the same structural way now, but what we would look to do, and what we are doing on projects currently, is we're making sure that the facade is non-load bearing, completely non-combustible, but we're able to make the rest of the structure out of timber. And because we're working in central London for commercially driven clients, we're very rarely, it's only been recently since the climate emergencies come forward, have clients actually come to us and said, how do we develop a sustainable building? Typically, all of our projects have been run and designed in timber because of the other benefits that they drive commercially, which is that typically delivering on a 20% quicker program, up to 85% fewer deliveries, so that's less transport congestion in inner cities, less transport costs. It's 80% lighter in volume, and what that's meant is for buildings such as Dalston Lane, this was built over a tube station. So if it was built in concrete, it only would have been 4 stories tall, but we were able to deliver up to 11 stories because it was so much lighter than if we built it in concrete. And so here's a little section. So what we were able to do is if we were having to build it in concrete, we'd have to use long pile foundations, which would have interrupted the subway route. But instead, we're able to deliver the much lighter building on a concrete raft. This is a building that we've just completed in Shoreditch. So this is an office building using a hybrid of steel and CLT, where we try to use as much timber as possible. But we've used standard sections, bolted connection steels in the hope that when this building is easily demountable, and when it is demounted, the steels could potentially be reused, where we try to use as much timber as possible. This is a building that we created for a furniture manufacturer called Vitsu, where we work closely with the client to develop a systemized factory building, which they could extend and demount over time. So they hoped to only build 9 bays, and then as the company grew, they would build an extra bay as they needed it and as they rented it. And we designed this with them all out of timber. But actually, as the project grew, they decided to build it all in one go, which was a little bit unfortunate because we didn't get to test the growing and shrinking mechanism. But this is using a mixture of timber species and in a typology of building which is typically steel and plastic. we've been able to deliver a highly sustainable timber building. Some more pictures inside. It's a really nice place to work. Just so comfortable to be inside. It's so serene. I mean, everybody who works there loves it. I'm a little bit jealous I can't work there myself. We've recently done an audit of 100 UK projects which have been built in CLT, and it's a free book that you're able to download from thinkwood.com/CLT book. And so while our government is currently trying to make it harder to build out of timber, we find internationally there are big strides to making more and more people take timber to be their number one choice to look for and come up with reasons of why you can't build with timber, rather than, I'm standing here trying to argue why you should be building in timber, but actually I feel like the conversation should be reversed, and actually everybody should be asking themselves why are they not building in timber. And the French understand this, the Americans understand it, the Australians understand it. Everyone's looking at how they can build more with timber, and we need to be doing the same. And so here's a little comic that you can also find on our website, which is sort of trying to explain the process as to how CLT can save the world. And the idea is that we can create these long-term carbon stores in the homes that we live in the offices that we work in, and encourage afforestation, so the more timber which is harvested to create trees from sustainable forests will increase the demand for timber, which will mean the more trees are planted, more carbon is sequestered. And then we can actually start making a significant dent into the amount of carbon sequestration that we need. Great. Thank you very much.
Thank you, Alistair. I think really interestingly, a relatively small practice having a huge impact on the built environment and the world of design at the moment. Okay, I'd like to introduce our third speaker, who is Matthew Barnett Howland. He's Director of Research and Development at CSK Architects in Eton. He's responsible for developing the practice's whole life approach to the design of environmentally sustainable buildings. He led the research, design and construction of the multi-award-winning Cork House, a pilot project for an innovative solid cork construction kit with outstanding whole life performance. Over to you, Matthew.
Hello. So I'm Matthew Barnett Howland from CSK Architects, and as well as developing the whole practice approach to sustainability in the form of a whole life approach to buildings, I also try and roll out that type of thinking across teaching and research as well. So the Cork House project was the result of about 5 or 6 years of research and development. So at its simplest level, Cork House is a collection of materials that come from the forest, a natural resource system. Cork and a range of timbers, from spruce CLT, Accoya for doors and windows and beams, cedar on the roof and oak floorboard and so on. The point is that they are materials from a natural resource system. Of course, I'm not an expert really on the sustainability of natural resource systems. My job really as an architect is to think about the way in which you can maintain the sustainability of those materials from natural resource systems throughout the whole life of a building and beyond. So during the development of the Cork House, we evolved an approach, form follows life cycle, which really, rather than it tries to reverse the normal way of designing, which is to develop a design and then think about how you can deliver it as sustainably as possible. We are interested in taking environmental sustainability first principles and putting those at the beginning of the conversation and asking the question in a way, what would buildings and architecture look like if you started with those considerations? And so it's also very important, I think, to architects and designers that we keep that conversation about sustainability very design-led, not let it become too quantitative, and always try and keep it a qualitative design conversation. As architects, we're interested in tangible physical environments, what they look like and smell like. And I think it's important to relate some of the imperceptible environmental impacts related to design and construction industry, and always try and talk about those as a designer in terms of qualitative environmental aspects. So that's how we usually talk about cork houses in relation to these 6 stages of its life cycle as a process, as I said, as much a process as it is a building fixed in time and space. In relation to this particular event, there are 3 key stages in that life cycle which make this an attempt at a sustainable form of architecture. So number 1, resource, obviously what we build with. 2, construction, how we build with that resource. And this talk will show how if you approach those 2 stages in a certain way, then your building becomes part of a sustainable relationship between natural resource systems and the production of human culture, on the other hand. And it's about that relationship I'm interested in as a designer. So starting with resource. So obviously cork comes from the Mediterranean rim in the cork oak forests. They've been grown and harvested and farmed for millennia, and as a result they're often referred to as human-shaped ecosystems. Cork is the bark of the cork oak tree, the outer bark, and it's harvested once every 9 years by hand in such a way that doesn't damage the tree or significantly disturb the forest. So it's slightly different to the conventional timber industry. And as a result of that sort of gentle form of agroforestry, which is then also combined with livestock and arable farming, it's an incredibly biodiverse landscape, from the Iberian lynx and the eagle, black pig. There's a huge population of Eurasian cranes which overwinter there, and so on. The best cork from the harvest is used for the wine stopper industry, which then generates quite a lot of waste on the right there. And also there's a lot of general low-grade waste from the cork forestry industry, which isn't usable by the wine stopper industry. That waste and byproduct cork is granulated, then cooked in these big pressure cookers using dry steam at about 360 degrees centigrade, which is generated using waste biomass from the cork industry. And as it's cooked, the granules expand and they release a natural resin in the cork called suberin. And that suberin melts and then bonds all the granules back together. So the lovely thing about expanded cork, and it's different to agglomerated or composite cork, which you see around lots of household products. Expanded cork is a pure, biorenewable, plant-based engineered product. It's only made of 100% cork, no additional ingredients or binders whatsoever. And because of that, it's already sold as a form of soil aerator, because it can be put straight back into the soil to biodegrade. And as a result of that sort of material life cycle, it's something approaching a bit like a cradle-to-cradle material, perhaps, where it comes from the forest. It's used in the technical cycle as a form of engineered, pure plant-based material, and as a result can go back to the forest and regenerate new growth. So those are the sort of characteristics that we were interested in maintaining through the life cycle of the building, throughout its use in the technosphere, if you like. So a lot of contemporary construction ends its life like this. And that's largely down to the way that we have come to think about the way that we make buildings and put materials together. So it's always interesting, people talk about their brick house, and of course a lot of people know that brick houses are in fact an agglomeration of a whole range of interesting materials, from cement-based blocks, petrol-based foam, insulation, foils, cement-based mortars, membranes, plastic insulation, and so on. And this creates a complexity throughout the whole of a building life cycle, not just in terms of tracking the resource impacts, but also at design stage, through to on-site complexities of sequencing and interfacing, aggregate performance in use, and as I just showed you, particularly at the end of the building's life. And we characterize that way of thinking about buildings as a complex, layered building envelope, where each function of the building envelope that it has to perform is fulfilled through a different product or layer, if you like. So structure, insulation, cladding, weather tightness, air tightness, internal finishes, and so on. And the hypothesis for the project was, could we replace all of those individual layers, those separate layers, with a single plant-based material, expanded cork. So from internal finishes, external cladding, insulation, its main function, load-bearing capacity, and also the transfer of moisture across the building envelope. It's a breathable form of insulation. So that was the original hypothesis. Could we replace the model on the left with the model on the right and still meet contemporary building performance requirements and regulations? So the approach started with a very simple idea of big blocks of cork that are machined into a tongue and groove system, interlocking system, friction fit, a kind of giant organic Lego system, if you like. Actually, I would say a bit more. So one of the interesting things about trying to use a single material across the whole of the building envelope, and it sounds like a really simple idea, but of course simplicity and complexity always have quite an interesting relationship, is that in order to maintain that material simplicity, we were asking that material to do a whole range of jobs, and that ended up with quite a complex block geometry on the right there. Those are the roof blocks. You can see how that got quite complicated. So then we had to turn to a form of digital fabrication, to address that level of complexity of machining, but also what this enabled was it's a very precise form of fabrication. So it meant that we could actually think about using this system as a dry jointed form of assembly, which obviously is essential in relation to maintaining the purity of this material throughout the whole of its life cycle within the building. And that's on the left there is the first section of solid cork wall that we developed at the Bartlett using digital fabrication. And on the right is the cork house on site. And you can, we will say that's obviously quite a good day on the right there, where everything fitted together really lightly. So this building's about 18 meters long, and the blocks have a plus or minus half a millimeter of tolerance. And so on a nice day, as I say, there's a rubber mallet there. Little rubber mallet, and you just tamp it down and it feels lovely. And of course there were days when it didn't look like that, and other tools came into use. So the cork system is combined, as I said at the beginning, with a range of timber products. So from spruce CLT for the floor and these structural wardrobes, and then a Koya ring beam that goes all around the perimeter, which is connected to a series of Koya valley beams. And they tie down to these structural wardrobes, and they stop the whole building going in terms of lateral stability, in terms of shear. So the cork take, well actually, I'll do the next one. Yeah. So this combination of cork and timber and some other elements together formed what we call the cork construction kit, which is a completely off-site, prefabricated kit of parts. So we designed and drew all these, sent them off to various range of suppliers and fabricators, and they got sent back to site, and I assembled them by hand on site. So you can see that the removable steel screw pile foundations, a Koya ring beam sits on the top of that, CLT floor plates slot into that, cork blocks in compression, and then a ladder beam at eaves level there in a Koya, which deals with the shear, as I said, and then more cork and compression, and then the roof lights on top of that, which act like paperweights, because there's no glue or mortar in the whole system holding the structural system down. Obviously, there had to be something, so they're just paperweights to resist the wind load for those top few layers of the roof. So the form of the building, as I said at the beginning, the form relates directly to a series of decisions made in relation to the consideration of the life cycle. It's a result of a way of thinking.
Now, I've been told even an idiot such as me can have a go at doing a bit of construction, so let's see if this really is idiot-proof. And, oh, it really is like building blocks. This is, I think, a roof. And there we go. In. Up. Out there. I think I've just built a wall. Not brilliant, but that was about a minute, wasn't it? Amazing.
Yeah. So, as I said, if you get in terms of what you build with and how you build with it, then this end of life phase is the result. So, in terms of quantifiable information, this is it's carbon negative at completion. So you can see on the left there, you probably can't see on the left at all. Anyway, on the left, it's saying that a lot of carbon is sequestered in the cork and timber. Yeah. There, that's transport. Just an interesting note, because obviously all the cork comes from Portugal, and a lot of the CLT came from Estonia. So we lose about half of the sequestered carbon in the raw materials in transport. But nonetheless, at practical completion, it is carbon negative. In terms of whole life carbon, on the left there is the cork house. Blue is embodied carbon. Operational carbon is in orange, and you can see it has the lowest. It is the lowest whole life carbon that Sturgis Carbon Profiling ever assessed. And Simon Sturgis is the person that wrote the approved methodology for whole life carbon assessment. It's interesting that just to go what Gary said about the 2030 climate challenge, which is interesting because, as Gary said, it's about 300 kilograms of carbon dioxide per metre squared is the target for 2030. Cork House is made almost entirely out of massive amounts of cork and timber and very little else. And it just at 286 on the left there in blue, it just comes under the 2030 target. So make of that what you will. How do I get that one to play? No, sorry. No, it should be a video. There we go. This is a little animation just to convey the idea that it is designed for assembly and disassembly. It's a whole kit of parts that are dry jointed together with no mortar glue. So all the connections on the left there you can see are all screwed and bolted. Everything is accessible and demountable throughout the whole system. And we proved that during the research, where we made this prototype, the cork cabin on the left there, in 2 phases in the Bartlett workshop, and then we took it apart again and disassembled it for transport, took it to site and reassembled it in the form of the cork cabin, so we sort of proof of concept for this idea. So instead of this, you have this, the cork house life cycle, so-called forest to forest. Comes from a biodiverse landscape, made of waste and byproducts, cooked without additional ingredients, put together on site without mortar or glue. The form of the building relates to these life cycle decisions, and then at the end of the building's life, the whole building can be disassembled, the blocks can be recovered for reuse, recycling back into the manufacturing chain, or if there's any waste from that, so-called waste, then it can go back into the biosphere, back into the forest, and regenerate new growth. And as I said at the beginning, so that's what I'm interested in, is the relationship between natural resource systems and the production of human culture, using those natural resource systems in such a way that there's a regenerative relationship between those two systems. Thanks.
Thank you, Matthew. Really inspiring. Nice closed-loop systems there. Okay, our final speaker is Justin Peckham from Accoya. I don't have anything else in terms of a biography, so all I can say is I've used Accoya timber since 2008, and it's amazing, and you're going to tell us about it.
How much time have I got, Duncan?
Sorry?
How much time?
Oh, a minute.
Good morning, ladies and gentlemen. So this is me. I've worked for the company that manufactures Accoya for upwards of 12 years now, mainly in a commercial role, but a large part of my role is talking to architects, helping with specification. And of course, the subject of sustainability often comes up in that context. A little bit of an overview of the company. Top left there, you'll see our statement, changing wood to changing the world. Now that might seem like an ambitious, even possibly arrogant statement, but it's something that we passionately believe in as a company. We've heard earlier various speakers talking about the benefits of timber and the role that it can play in hopefully reversing climate change. And one of the big challenges with timber, of course, is that it rots. And so whilst we can quite safely use it internally and lock carbon in within the building envelope for long periods of time, there's a challenge when you're using timber externally to make it last a long time. And that's what we're offering here. There's a solution for that. So we have a factory in the Netherlands that produces Accoya from the conversion of sustainably grown, rapidly grown plantation softwoods using a process, scientists call it acetylation. You can think of it as pickling the wood if you like. We're not using any nasty chemicals. This is not treatment of wood. We are actually changing the chemistry of the wood in the cell wall that then restricts the uptake of water into the cell walls of the wood and thereby stops the rotting. Rotting cannot take place if there's not water in the cell walls of the wood. And the other big benefit of Accoya is that by keeping water out of the cell walls of the wood, we severely restrict the amount of movement in that wood. And one of the big challenges of working with wood, I think Matthew alluded to it earlier with the cork, is that it moves with changes in humidity. And that's the other big strength of Accoya. You don't get nearly so much movement. So we have one factory in the Netherlands at the moment, ambitious plans to grow in production, but from there we are selling Accoya to a number of regions around the world. And the UK is currently our biggest market and an area of focus for us. The main core attributes of Accoya, as I said, it's very durable, very stable, and it's produced in a sustainable manner. And the majority of applications, not 100%, but the majority of applications are external. So it's used a lot now for external joinery, also for cladding or decking, in landscaping applications, street furniture, planters, all sorts of applications externally. There was always going to be risk being the last speaker that I'm going to go over ground already covered by others, but just repeat the sales pattern for wood, I suppose. It is probably one of the oldest building materials known to man, and responsibly sourced, it is the only way that we can remove CO2 from the atmosphere, lock it up for a long time, and help reverse climate change. One of the benefits of working with wood is that actually just processing of wood takes up a lot less energy than working with man-made materials, metals, for example, plastics. And another big benefit, not really touched on yet, is that there are mental health benefits to working with wood. There are material health benefits for working with wood. And people just seeing wood around us has been shown to have a lot of benefits. So there are benefits to using wood that go beyond just helping to reverse climate change. And actually the last point is very valid as well, and alluded to by speakers before. End of use, timber can be reworked quite simply and recycled, upcycled, reused. It's not, doesn't have to be thrown into landfill. So what are the particular benefits of Accoya? In the context of helping with climate change, I guess the main benefit is the durability. We are locking that carbon in for a lot longer than there would be in terms of natural, fast-grown softwoods. Yes, there is a carbon cost to doing that. Every process has a carbon cost. But various studies, many studies, have shown that there is a net benefit. We are locking that carbon in for a lot longer than it would be there, generally speaking. Because of keeping moisture out of the cell walls of the wood. Accoya, in any given atmospheric conditions, will tend to have a lot lower moisture content than other timbers, and that has obvious benefits in terms of insulation. So in use, there are benefits to using Accoya windows and doors, for example, in terms of a better insulation performance, everything else being equal, than certainly hardwoods and to some degree softwoods as well. We're very proud of the fact that Accoya has achieved overall gold status on Cradle to Cradle, and we're present on the stand over to the left of us, or to your right. And in terms of the material health side of it, we've even achieved the platinum level, the very highest level. And this in itself can lead to benefits under LEED or BREEAM projects. This is where I'm repeating some figures quoted earlier. I think Duncan quoted the figure of about 45% of the CO2 emissions nationally are contributed by construction. These are slightly different figures. This is saying that 45%, the construction has the ability to influence 45% of the CO2 emissions. And of the emissions influenced by construction, roughly 80%, 83% I think, is related to in-use. So a lot to do with insulation, for example. But a significant 15% is down to the materials used in the construction and the CO2 generated in the manufacture of those materials. So it is a really important element when we're considering how we can mitigate against climate change, the use of the correct materials. Again, I'm repeating what others have said, Gary in particular here, but forests are really important. They're the only natural way on a large scale that we can take carbon out of the atmosphere and lock it up for periods of time. And by using wood that is grown in plantations growing rapidly, we are locking carbon up more rapidly in the atmosphere than, for example, mature forests. The traditional way of making wood or using wood externally and needing that durability is to use tropical hardwoods. Now, tropical hardwoods take a long time to grow. They're typically growing 150, 180 years, and then in use, they're only lasting 40, 50, 60 years in general. What our process allows us to do is to use fast-grown softwoods. They're reaching sawmilling maturity in less than 30 years, and from that we're making a material which will last externally for at least 60 years. So you can see we can regrow the trees more rapidly than we're wearing the wood out, and that's not possible with natural grown temperate or tropical hardwoods, for example. So there are trees and there are trees, and the mature forests have huge benefits in terms of ecosystems and so on, but they're not the most efficient way of using the wood. Plantation wood grown either for internal or external use is the best way of capitalizing on this ability of trees to capture carbon from the atmosphere. Another benefit of Accoya is that the durability and the stability means less maintenance. For example, the main reason that coatings fail on timber is nothing to do with exposure to UV light, for example, well, not primarily, or effects of the weather. It's because the timber as a substrate underneath is constantly moving with changes in humidity, and the coatings then have to move with the substrate, and that puts stresses on the coatings, and eventually they become brittle and give up, and we've all seen paint peeling off wood. Because Accoya is a much more stable substrate, there's a lot less stress put on these coatings, so they last a lot longer, hence reduced maintenance requirements and reduction in the energy associated with that. We've heard mention of the RIBA Climate Challenge already, so I won't dwell too much on that, except to point out that they have set 8 sustainable outcomes as part of this challenge. And looking through that list, I identified 3 particular areas where I think the use of timber, the use of Accoya can help with that. The net zero embodied carbon, we've already seen figures earlier about, from Alistair about how use of timber can actually end up with a negative embodied carbon and helps offset positive embodied carbons elsewhere. Good health and well-being is another outcome, and I've already spoken about the benefits of timber for that. And sustainable life costs, we've heard discussion of that earlier as well. So it's a use of timber greater use of timber, should I say, will help go a long way towards meeting this climate challenge, as ambitious as it is. And I've just put a quote at the bottom there from RIBA. This came direct from their website. Finally, just a few projects where Accoya has been used around the world, including the Cork House here. A lot of applications where people have shied away from other timbers but are using Accoya where they wouldn't have otherwise used timber. We've seen applications where Accoya has been used instead of concrete or steel or aluminium, for example. So we're not looking just to replace other applications of timber. We're looking to take timber into realms where it's not currently being used. So, Duncan, that was really all I wanted to say.
Thank you, Justin. Can we have a round of applause for Justin? Okay, could I ask the speakers all to come and sit up the front? Do we have any questions from the floor? Okay, we do have one already. So if I ask if you can come to the front. I'll go this way.
Hello, Claire Neely, London Borough of Southwark. I work with the in-house repairs and maintenance contractors, so we're lots of dry rot, lots of damp, and so on. But my question was, and you may have covered it, but I was trying to deal with some stuff. Fire spread.
Well, I'm speaking, yeah. I'll start with that then. So I'm talking really from the perspective of exterior facades, and that is certainly a challenge for timber. Alistair alluded to earlier as part of the structure of the walls, and it's a challenge to the use of Accoya externally. It is possible to treat Accoya to achieve a material that makes it suitable for use in Euroclass B, but as we know, Euroclass B isn't going to be good enough for a lot of the buildings going forward, especially higher rise. I mean, it doesn't preclude it from use in smaller residential buildings. That's certainly, there's a solution there, but there is this conflict going on, I think, between the desire to use more timber and other building regulations which are going against it.
Sure. I really would like Alistair to comment next, because you've had to dodge the regs recently. So
Yeah, well, it's not so much dodging the regs. One of the main, because we're designing timber, one of the primary focuses of all of our projects has been fire. So we've worked with really good fire engineers on all of our projects and continue to do so. And there's a lot of misunderstanding with the products that we design with, as opposed to stick frame timber. So the projects that we design with are mass timber products. So it's large-scale, thick timber, which creates compartments. So your party walls are a solid timber structure. Your external wall used to be, and in lower-rise buildings still is, a solid timber product. And what happens to that timber under fire? And you have to think about it like you're making a bonfire. So if you're making a bonfire, you don't throw a big log on the bonfire and try and hold a lighter to it. You're not going to get very far with that. You have to provide it with fuel and smaller bits. But even then, to get that log burning, it needs maintain a really high temperature and flame next to it for a long period of time at a high temperature. And then what happens is the timber starts to char. So the timber stars won't go into all of the science. But basically when the gases are created and leave the timber and create a charring layer, which then insulates the inner core of the timber. And so what we're able to do there with fire testing and modeling is we're able to see how long that timber wall will last under a fire. And what we typically design for is burnout of a fire. So if a building of a certain height has a fire in it, it's adjudged that the fire will burn out. So all the fuel will be gone by 60 minutes, 90 minutes, 120 minutes, 240 minutes. It's different regulations and different use classes within the buildings require different time limits, but you're able to sort of judge when is that fuel load going to be extinguished, and can the structure withhold that fire and contain that fire. So one thing which CLT actually works really well for is containing the fire. Because of it's incredibly airtight and very thick and durable, it can actually contain the fire within itself. There's great videos on YouTube if
Thank you.
that's your thing.
I think Gary wants to say something. Sorry.
Yeah, just, is that on?
Yep.
Yeah, just to add a small point, that fire safety is absolutely key and shouldn't be messed with, but it's not a question of combustible materials or not combustible materials. That's way too simplistic. Fire doors, what are they made from?
Timber.
Wood, right? Because they're fire safe. So fire safety is key. I would argue that a bigger problem that we have in the construction sector, if we're moving to a massively expanded use of timber, is moisture, and understanding how to use wood well to avoid moisture getting in and causing degradation. That's the big issue for me, not fire. And it's a real shame that the regulatory framework has created this paranoia about the use of timber. Timber wasn't used in Grenfell Tower, and its toxicity of materials that was largely responsible for deaths and bad design. So that's my only point.
Well, yeah, and oil-based fossil fuel things going up in flames, not timber. Have we got another question? Yes.
Hi, Ian Poole from Mott MacDonald. I'm a structural design engineer. You mentioned at the start of the talk that UK is the second largest importer of timber in the world, and if we specify more in our projects in the UK, we're going to be increasing that amount. At the same time, we've got increased demand in other countries where the timber is closer to home, I guess, such as France, as you mentioned. So my question's around how do we link up the supply chain if we're increasing our timber design and timber demand in the UK? Is it the right thing to be doing if we're then transporting it further than it needs to and maybe taking it away from other countries that need it? And also, timber takes time to grow. Is there enough timber now currently being grown for us to specify on projects that are going to be built in the next couple of years?
Yeah,
Gary.
really good whole bunch of questions there. Wood's used for all sorts of things, right? So biomass for burning, it's used for pallet manufacturing, furniture, MDF, OSB, huge range of products. If there's a massive surge in demand for timber, the short answer is, who knows? At the moment, the cost of wood is very low from the continent because there's a tree disease, and so they're harvesting quite a lot of wood, so there's a glut. And we're not at, I don't think we're close to peak harvest of wood, the amount of wood we could be using. So there is more that we can take sustainably from the European forest resource. In fact, European forests are expanding. The question is how quickly our country is going to switch on to planting more timber. You can see from France, Macron saying that 50% of their buildings are going to be based on, public buildings are going to be based on timber. You know, so I'm imagining it's going to be a challenge. And I think wood will move from low-value applications, such as burning it for biomass, which actually isn't particularly sustainable, to much higher value applications. And I think that's what will happen first. I'm not imagining a scenario where it comes in short supply. I know in Scotland there's a massive drive to plant trees. In Wales there's an aspiration, they just haven't managed to work out how to do it. Land and use of land is a very controversial question. But as a planet, we are nowhere near maxed out on the wood that we can grow. And the rotation now for timber in Wales is about 40 years, but there are new, not species, faster, they've been bred to grow quicker, and that brings the rotation down to about 30 years. In other countries, actually, there's a rotation of about 20, the warmer. Wet and warm is good for fast grown, right? And Wales is pretty wet and warm. So who knows in the future whether we can increase supply at the scale that I think is needed. It's entirely possible, but it does require political will because land is always contested.
And there are other supplies coming online in the UK. I mean, where I live on the south coast in Brighton, South Downs, we've got ash dieback. It's all being cut down at the moment. We've suddenly got a huge amount of timber. I'm using it already on projects. But we've also got sweet chestnut, coppice sweet chestnut, which is a fast-growing hardwood at the end of the day. So on a 25 to 30-year cycle, we use it for glue-laminated structures, cladding. But Accoya is amazing because there's also a lot of low-grade timber out there. And the thing I've always liked about Accoya is it sort of upgrades low-grade timber so it performs like a hardwood. Did anybody else want to comment about that?
Yeah, just to add to that, we haven't spoken about it, but our company has another product called Tricoya, which, those of you not familiar with it, is effectively the panel version of Accoya. And it looks just like an MDF product, but the wood fibers are Accoya. So again, that, like Accoya, has a 50-year warranty in external applications. And the great benefit of that is that we can use all the waste wood from our factory, for example, goes into that. And we're building a new factory at the moment in the UK to take chipped wood from our forests. So it doesn't have to be the best wood. And we can turn that into a highly durable, long-lasting, valuable product.
Can we have... Oh, yeah, go on.
Sorry, just very quickly, I just wanted to say it's a really exciting time for timber at the moment because while most of the technologies that we've used are based on spruce timbers, there's a lot of unused timbers in other species around Europe, North America. I mean, a massive abundant supply of tulip wood in America and large supply of beech. As soon as beech furniture went out of fashion in the late 70s, it's only really being used for burning. And so there's a lot better, more sustainable uses that we can do with European beech supply, like making LVL. And as the demand for timber grows, I think the technology will move with it. And we'll start looking to use the timbers which are available to use and start using technologies to make softwoods more durable.
Matthew's going to talk. Come on.
Yeah, just say, I think it's really important that we don't use that conversation, as I've heard quite a few people do recently, as a reason, not to try to build in timber. I've heard it wheeled out several times recently as reasons to carry on using other building products. I think in terms of the market and pricing mechanisms, combined with regulation and certification stewardship systems, then just let's build with it, and then and with some political will, I think it's possible. But don't use it as an excuse to carry on using the same old crap.
That's a good point. We've got tens of thousands of hectares of standing sweet chestnut in Sussex and Kent, around London actually, and it's not being worked at the moment. And these working woodlands need to be worked. They create a higher level of biodiversity if you work them than if you leave them alone. Can we have another question then? Yeah.
Hi, fantastic talks. Thank you. I wondered what you think we need the government and local authorities to do very quickly, and what can we do to support that? I mean, I know in kind of the work I've done with Duncan, there's stupid VAT on materials when you renovate or retrofit. So people are demolishing buildings because there's no VAT on the materials when you build new. And, you know, we've been banging on for 6 years to Westminster about that. So I wondered, what is it in your world that we need to fix?
Gary.
Okay, yeah, I mean, I speak for Wales, if that's okay. Our strategy is to get housing associations and local authorities to buy into timber, basically, and they're up for it. So 1 out of every 3 houses in Wales is built by government, so they're paying for it. And at the moment, they're paying for plastic windows, so they're paying for gazillions of UPVC windows, which are lasting about 15 years and going to landfill. They don't want to do that anymore. So, you know, it's an open door at the moment. Regulation would be nice, but local authorities and housing associations that I'm working with are not waiting, but they're moving faster. Powys have instigated a wood encouragement policy to say that all their council houses will be built using the timber supply chain. You know, it could happen at pace. The nice thing is that councils haven't built houses for the past 30 years in Wales, so they're starting from scratch.
Yeah.
So why would you start doing all the wrong things? You know, they don't want to do that. So it's an open door. Regulation would be nice. There's lots of talk, but, you know, the lobbying comes in and they all get a bit worried and they run scared. So the critical thing is that we have to prove you can do it with the people that want to do it. Then the regulations will follow, once you've shown that it's entirely possible, in my
Matthew?
opinion.
I know you don't want to answer. You can move it on if you want, but come on.
Yeah, I mean, as architects, we obviously do need much tougher regulation in terms of embodied carbon. I mean, David Mickar put it nicely at the Sterling Prize Award this year. He said, you can't expect us, architects, to stand up in front of clients, or the suits, as he calls them, and look like the crusties in the room. You know, it's just a rubbish position to be in. You know, they're paying your fees, and then you're there preaching to them, and it's just the wrong way round, you know.
Couple of points I would make. One Gary alluded to earlier. A possible benefit of Brexit is that it allows us to review the Common Agricultural Policy and get rid of the stupid system of overgrazing and uplands, and we should be planting that with trees instead. And then there's a second point. It's not really a government action, but I would like to see a climate develop where people are able to put a value on the recyclability of the buildings in a material, of the materials in a building, so that goes down as on the balance sheet for the building, if you like. And that will encourage people to use more recyclable materials.
I think government are a great client in the fact that they build buildings to own the buildings, to use the building for a long time, and to service a large volume of housing. And so I think that they are in a great place to show how timber can be used and how they can build with the lowest amount of energy. And I think that they should be sort of using it as a tool to test, develop, and sort of show to the rest of the industry how it should be done.
Do we have any more questions? We can have one.
But one more thing, I would like to say that the combustibles ban is up for renew again, and so there is a site on the government website where you can put back feedback. And my view would be to say, don't support a complete ban, but support a ban of combustibles unless testing can prove performance of the material. So current legislation is heading towards a complete ban of combustible materials, which includes timber. Well, actually, it should be a science-based decision where you can prove by science that timber is the correct solution for the job, and that should be an allowed way to compliance. And we're all allowed to state our views on that.
Thank you, Alistair. Do we have any more questions? Oh, one more again.
This isn't a question, it's a comment. UPVC windows are murder to maintain, so in fact they have and as are the effing composite windows, and so they have a much shorter life than 15 years.
Good point. Okay, can we have a round of applause for our speakers? That was fascinating.